Okay. I thought that was normal for it to be like.
No, sure it is. Okay, we're live.
Okay. Yeah. So I thought I'd go over briefly the Neuralink announcements last night. If you guys follow neuroscience Twitter or on science Twitter, it's the big news. Everyone's talking about it in neuroscience Twitter. What I found, there were a couple of really interesting meta comments I have about this whole thing. So obviously they made a big deal out of it and it got a tremendous amount of press today. But what was really interesting to me is that this event that Elon Musk had, it was live tweeted by multiple neuroscientists, which I've never seen before. And so here's an example. I don't know if you remember Andrew, he was at our Banbury conference, but he's one of a few people that he did a really nice job with this. So he was basically live tweeting it, and this I found to be super helpful. And it's much easier to read his tweets, which are very informative about what's going on, than to, it's much faster, more efficient, and you get color on it, which is really good. So I thought that was quite novel.
Does he work in this field? Is he one of the people?
Yeah, so he's an experimental neuroscientist at USC.
But works with probes.
Works with probes.
Yeah.
He does sensory motor integration and with whispers, but this would be, I think he's working on using neuropixels probes. I think so.
I think the reason a lot of neuroscience would be interested because of that.
Yeah.
They use these techniques anyway.
Yeah.
It's not that most of them sit around thinking about doing brain-machine interfaces. So.
Right. And if you also, one other interesting thing I found is that before the event, the scientists were quite skeptical about it. I think mainly because it's Elon Musk and they're making lots of claims about it and a lot of drama. And so scientists naturally tend to be skeptical about this stuff. But they kind of left somewhat impressed, actually, the scientists. So even though there was a lot of hype, it's actually not an unreasonable thing that they're doing. And I think the summary, he had a really nice summary here. So basically, the summary is Neuralink picked the best of existing technology and pushed it forward in a number of important dimensions, and most impressively has an integrated, implantable product that goes beyond the current state of the art. So that's a pretty positive statement from a scientist. And there were several others like that.
Can we buy it from mice?
Can we buy it from mice?
That's their interest.
Yeah. And if you kind of this kind of summarizes it, it's not that any one of these things is that radically new, but what experimental neuroscientists often do is they get these parts and they create their own rigs and their own devices. Here it's like a really nicely packaged thing with a couple of really nice, interesting twists that I'll get to in a bit. But it's sort of packaged almost like a product, which is interesting for this kind of stuff. This stuff was the other meta comment is. All of this live tweeting was actually picked up by journalists. So this is in the BBC. They quoted Andrew and they quoted Conrad Cording was another live. Anyway, there are a bunch of people live tweeting it. So that's kind of interesting.
It makes you what it looks like.
Yeah. So this is another example of a fairly positive statement.
So do you think they have been testing this technology, that Neuralink has been testing this technology in mice so far, exclusively?
I saw one tweet that said they've also been testing it on monkeys.
Really?
Yeah, and they have applied, I believe, for implanting in humans now.
Right.
That's their ultimate goal. There's also tons of hype around it. So New York Times had a big article. This is the title of the BBC News article. Elon Musk reveals brain hacking plans.
Right at the end, talks about Kernel, the other company.
Yes, yeah.
So is that company, you know about it?
Well, there's been some discussion on it in the office last couple of days, but.
As in yesterday morning, this guy, Brian Johnson, emailed me.
Yeah.
Or was it Monday? I can't remember.
Yeah.
I think it was yesterday morning. Saying, hey, I want to get together and talk to you. Since I never even heard of these guys before, so I was trying to set up a conference call or call to him.
Yeah, I think so. For the purpose of this kind of live streaming, Neuralink is not the only firm building it, but there are other firms. But certainly he's not going to get as much hype as Elon Musk does on this. Okay, so what else? So the overall tone, I think, was pretty positive. Another kind of meta comment. So this paper was posted on bioRxiv. I think it showed up this morning, or I think they must have posted it yesterday. Just look at the authorship.
That jumped right out of me. It's a weird authorship.
It's so weird, yeah.
What is that supposed to mean? It's like,
I don't know, but why not name a few other
Yeah,
scientists who are
exactly.
involved? There's some famous scientists that are in Neuralink. It's so bizarre.
I wonder if he wrote the entire thing himself. Is that possible? And then
No,
he
it's just taking credit.
or did he not and just didn't want to look like a single author? I mean, it's weird.
I don't think he wrote this himself. I would be amazed if he
Then
wrote
I
this.
can't imagine why he couldn't possibly list the name of the people who actually wrote that.
Ego?
That's pretty amazing. I mean, he's a really smart guy, but is he that much of an egotist that he wouldn't want to give credit to other people?
I don't know.
There might have been a thing where they didn't know where to stop. If you credit one neuroscientist in Neuralink,
Fine,
soon you have to
put
list
20 on
everyone.
there.
Yeah, put
okay.
a
wrong with that?
Sure,
There
sure.
are papers that have,
Fair.
tons of
they
dozens
find
of
a paper,
names.
they just put like
Yeah.
30, 40 people, they just
Yeah.
put everyone there.
I mean, this is almost, it could be a marketing thing, like, okay, we want Elon's name in there from a marketing point of view, and we don't want to dilute it with other people.
Yeah,
But this is a paper.
But from a scientific
Yeah,
standpoint,
from
that's
the
not
paper
what you
point of
do.
view, this seems crazy.
yeah. So that's that kind of jumped out. So in terms of the actual technology, there are a few different parts to it. One is the first part. So these are implantable probes that go into the cortex. So this is two different designs for their probes. Let's see if everyone can see it. They have these linear. So this is a single kind of thread that goes in vertically into the cortex, and each of these white dots would be a channel that you record from.
So this is, are we seeing multiple threads horizontally here?
Yeah,
This
yeah.
is not a single, this is like 7 probes.
Yeah, there's 7 probes. And then this is another design where you have, I think they call it a tree structure probe, where these channels are hanging off to the side, so you can get a higher density of channels here. So these are two designs that they're working with.
Are they designed to be removable?
What's that?
Are they designed to be removable? Do you know? Is that something they discussed?
Remove.
I don't know. I think so. I think you can just take them out, but yeah.
I don't think you'd like reposition them.
You can't reposition
It's not like,
them.
oh, try here, no, let's try over here.
One thing that's left out of it is kind of the lifetime of these probes. Typically, they don't last super long, and certainly not for your lifetime. So that's an issue that they briefly addressed in the paper, but they didn't really get into it.
But how long, like 10, 20 years?
Oh, no. Typically, it's weeks.
Well, I think one of their claims
What?
here is that
I think one of their claims is they will go longer, but quite often it's not that.
Then you just have to switch.
Or maybe it's months. They can go to. I doubt they can go years.
there's the life of the probe, but there's the life of the usability of the probe,
Yeah.
and they're not the same. So the probes they typically use today are more hard. They're there's this array of little spikes and stuff, and they're not flexible as much, I think. And so the problem with those is that even when the usability changes because as the brain moves and pulsates and so on, you lose contact with the same cells. So these things are only useful to the extent that you're contacting the same cells or measuring the same places in the brain. And I think one of their claims here is that unlike the more fixed probes, which just inherently are not continually usable because the brain is moving and they're not, these are more flexible and therefore would be more likely to stay in place. They'd have a longer usable life.
But even if they stay in play, are they measuring the same activity? Because the brain is also changing, right? Like
Yeah.
the nerves are
Well,
not-
but the most important thing is to be measuring the same cells or the pericellular activity that's there. I mean, you don't want to slip into make it completely different. What the cells may represent could change, but at a minimum, you want to be measuring the same place in the brain.
Yeah. it's difficult to measure to really be guaranteed that you're measuring the same cells over time. And in fact, there's really no way to know, typically.
But this is one of the, today when they do these implants in people and so on, they don't last very long at all. This maybe could be a couple of days because they program the machine to recognize these patterns, and then 2 days later they're picking up different patterns, different places in the brain. So then they have to train all over again. So it's, you know.
Yeah, if they don't do it right, all sorts of like, the brain has all these defense mechanisms. I mean, your body has defense mechanisms. So this is a foreign thing coming in. So, you know, scar tissue and other stuff can build up around it, and that can also.
So,
It could
okay,
be
so
right
when you
there.
say that these decays, not the material that decays, but.
I don't know about the material. I'm just saying the
It's
usability.
So
All of
The
these, all
usability-
of these are factors.
I don't know about the decay of the material. But I
They
do know that-
mentioned, they didn't really address it, but they mentioned it very briefly at the end. Let's see.
I don't think there are any long-term implantable probes that are highly specific today. So when they show people how this person has learned to control something from their brain, I don't aware of anything that's actually lasted long.
Yeah. They say the size and composition of the thin film probes are a better match for the material properties of brain tissue than the silicon probes, and therefore may exhibit enhanced biocompatibility. That means it'll basically be more reliable and last longer.
Yeah, the silicon stuff are pretty rigid. You know, it's hard.
So, so there. I think this has 32 channels, each one. This, and then they insert multiple threads like this, and so they have a version that has 3,000 independent channels.
Did you catch how long the threads are? What's the dimension? I saw 10
Well,
microns.
this is 100 micron scale bar.
Oh, right there.
So.
Right there. So that would be like 50 microns, 500 microns.
Something like that, yeah. In the discussion, they said they can even get to subcortical areas. So this,
so
I
they have
guess
to
this
get
is just,
longer then,
yeah.
so that-
And this is a little shorter. So that, these are all design parts. Yeah, so 32, and then each array of these things has 48 to 96 of these threads. So you can get something like 1,000 channels from a single array, and then you can implant multiple
The
arrays.
impression I have is that the other arrays that exist today are very rigid arrays. They're like embedded onto a chip or something like that. That these are not rigid. These are just sort of independent threads that are inserted independently. Is that
Yeah,
right?
yeah. But that has apparently been done before.
Oh,
They're
okay,
not the
right.
first to do this.
Okay.
And I learned that from Andrew.
Is that have other people done it in that kind of quantity before?
No, it's not being productized, but
I mean, I know
think
people
this-
have
these
individual
people-
threads like things they insert, but these guys are proposing doing a lot of them, right?
yeah, yeah. And so the next thing is, well, how do they do a lot of them? They've created this robot system for, they call a sewing machine for inserting these things into the brain. So
I
machine.
assume they're not really planning for safe extraction at this point. Seems kind of scary.
Well, removing them sounds easy, right? Just pull them out.
Yeah, I think you can just pull them out. I guess you have to be careful not to tear out part of the brain as part of it,
And that
because
would
it
only-
could get attached.
That
to
would
it.
only happen if the cellular material attached to it. I
Yeah,
guess.
yeah. So here's a video that was on bioRxiv of the sewing machine working. Oh, we might want to close the window. There's a thread here that you can't really see. Yeah, so you can see this. So
Oh,
this.
yeah, barely.
I thought that's one of his spaceships taking off.
It could be. So this is an existing thread, and there's a couple of things to notice in this video, but I'll just play this first. So here's the robot coming in, and boom, inserts a thread, and you see all this flashing going on, and then there's a delay, and then the next thread. So what's going on here, the robot is pretty impressive. What's going on is that the robot, automatically picks up the thread with this, you see this little loop here, so it picks it up, just like a sewing machine. It's like a needle in a sewing machine, and then it kind of plans the trajectory, and all those flashing lights that are going on is it's sort of registering against fiduciary points in the brain, and it can do a very precise kind of alignment and figure out where to do it. and they want to avoid the vasculature, so the blood vessels and stuff like that. They map those out, and they can avoid that. It apparently also tracks the motion of the brain, and can use, so it can very precisely insert these things.
But the whole
So-
brain moves quite a bit with
Yeah.
each heartbeat.
Yeah.
So the whole thing is like moving every heartbeat.
So it basically is independent. It can do it despite that. It can
Yeah.
track the motion. So it's a pretty impressive little device, and I don't think that's been done before. So you can see that's what all this flashing is going on, and the part of the delay is just that it's planning out exactly where to put things and time everything correctly.
Do you think this is a mouse brain, or is this just some kind of
That's
material?
agar.
blend? That's agar, yeah.
But what is it?
Agar?
Oh, so it's nothing.
That's-
Yeah,
yeah.
it's not a brain.
Not a brain.
Not a brain.
We can use it. You can put
Yeah.
implants into your
That's pretty
bowels
impressive to watch, though.
or
Yeah.
your pudding.
And they opened with that, so that was like the initial.
Yeah. So that's the robot. Yeah, there's the things. Here's the chip that's going to read all this stuff. So all those threads will be connected to this chip somehow.
Are beads the threads? What is bead?
Yeah, I guess the polymer threads on substrate. I guess I'm not exactly sure how it connects up.
It's an Apple Watch.
It's a USB-C. It's a USB-C port.
Yeah, yeah, you're gonna have a in your brain.
You can start imagining a brain.
It's the same thing. You can project from your brain is the USB-C. So that's the stuff, and then this is an example of all the threads in. They show they've done it in a rat.
Oh, so they have done it.
They have done it in a rat, yeah. And these are real recordings from the rat. Yeah, these are so this is a system where they did multiple simultaneous implants, and this is the recordings from over 1,000 neurons.
Is that 1,000 neurons or 1,000 local field potentials?
It has to be.
Okay, so they yeah, that's a good point. They do not do spike sorting, so they don't track individual neurons. What they do is they do spike detection, so they can detect when a neuron is fired, but for each contact there are multiple neurons around it, and to actually isolate neurons you have to look at multiple probes and do the spike sorting business. I think you can do it with a single probe too, but that's
You can look at the waveform to help us.
you can it's all computationally expensive, so you can't do that in real time.
Right.
So this is
Oh, they can't do that in real time?
they can't do spike sorting in real time, but they can do spike detection in real time, and so and this is pretty common in BMI. You don't do the spike sorting; you just look at spikes, and you assume you can get enough signal from that to do.
You can like threshold them and hope to get always the closest neuron or something.
Yeah.
Well, it matters in some applications and it doesn't matter in others. Depending what their ultimate goal here is. And, the proposed original ultimate goal was this whole sort of merging your brain with super intelligent computers. And that would likely require this very specific neuron connection. If you're doing prosthetic control, like for an injured person with an arm or something like that, then you probably don't need that.
Yeah.
But it could be that a better algorithm at some point in the future allows us to do spike sorting in real time
Maybe.
Yeah.
from LFP.
Yeah.
But I think there is a lot of signal in the waveform, and there's probably other ways as well to get it
Yeah.
differentiating.
But it's still going to be difficult. It'll be difficult anyway.
Yeah.
So yesterday they said they could read, but they could also emit signals to the brain using the same device.
Yeah.
How
So
does that work?
so it's the same. So with these devices, you can also stimulate locally the neurons.
Is it current injection or is it a voltage? Typically,
I don't know.
But you're not like on top of a neuron, right? You're close to the neuron.
You're close to a bunch of neurons.
So how do you know you're stimulating the right one?
You don't.
You don't. You just stimulate.
It's the same
nearby.
problem with reading. You don't really know which ones you're reading from.
Ah.
You're reading from a bunch of them, and so this is my point: is when they're just going to put a voltage or some current at some point in the brain, and it's going to act. It'll be near a bunch of dendrites. It'll be near a bunch of axons. It'll be near a bunch of cell bodies. It'll have a sort of a mass effect on a great number of different things.
Yeah, and it could be interneurons as well as excitatory neurons. So
Yeah.
it's a kind of a
But
pretty
imagine
broad.
in any piece of neural tissue, you've got axons and dendrites dominantly, and then some cell bodies nearby,
Yeah.
and you're going to be affecting all those things.
So what is the application of that? What does it do? How would somebody do that?
Experimentation. But there's also, I mean, there's like, have you heard of TDCS, like transcranial direct stimulation? That's like a really brute force version.
That's like you
on the
just put
outside.
something on the
And
top
just
of your
stimulate
brain.
activity, and they've seen the effects of various kinds.
No, of course. If you just what they do there is they use a magnetic pulse to induce a current in a large section of the brain, and that will, as any stimulation will do, it will invoke thoughts.
Well,
You-
so magnetic version knocks out activity. That's TMS.
Oh,
Is the one that you like hold over. You can only get a couple centimeters deep, and they use that for running experiments
Yeah.
that just like knock out an entire area.
yeah.
But then the TDCS, I think, is running just a straight voltage into the scalp.
Oh,
It's just devices
that
that
would
you
even
put on your
be
forehead.
that's even worse. He's got to
Yeah.
go through. It doesn't do anything. I mean, it's like so diffuse.
Yeah, I mean,
It's like
the evidence for
electroconvulsive
that having
therapy.
That's
a causal
You know.
effect is very unclear.
So it's a small version of electroconvulsive therapy.
Yeah.
But in general, they run experiments to see what certain brain areas are doing, so they can pump voltage into one area and just look at
Yeah.
subjective experience or.
So-
they could insert like knowledge somehow, so if they can insert
So
wow.
historically, this was done first by this guy Penfield, and what they were trying to do is they're gonna operate on your brain to remove some tissue, to remove basically an area that might be causing epileptic seizures, and so they want to know what the tissue does before they remove it, or maybe they won't remove it. So they would just on an open brain in a live patient. So you're awake on the operating table, you can't feel this. They would do a current injection into a small area of the brain, and they would ask you what you, if anything, if you noticed it. And you might say, oh, I hear a song, or I just saw my grandmother, or whatever, I just had a vision of something, or it was blue. And so they could say, oh, that's a vision thing, or whatever. And then they would try to isolate areas that might be related to language. And so they want to pick an area that doesn't look like it was, they want to exercise a certain amount of tissue, but they don't want to exercise tissue that would leave you deaf or leave you language deficits. So that's how this originally went about, is to identify what this little area of the cortex is doing, so can they remove it without having any very broad noticeable effects. But I think what Musk wants to do ultimately, and I don't know if they talked about this last night.
I'm sure they did. I didn't watch the whole video.
His original motivation for doing this is he's afraid of super intelligent AI, and that these machines, the intelligence explosion machine, this idea of the intelligence explosion, that these AIs are going to get so smart so fast that they'll leave us behind. So his idea is we should be able to plug our brains directly into the computer so that we're not left behind. So as the AIs get super intelligent, we get to go along with them. And for that to occur, you have to have a very high bandwidth, high capacity, very targeted bi-directional communication at a minimum. So that's why they want to be able to go both ways. I think in the short term, there's going to be this opportunity for both neuroscience research and prosthetics. And in those cases, especially on the prosthetic, you don't need to integrate the brain, you just need to read out.
Well, proprioception is useful though, to get proprioception into.
Yeah,
the
but
brains.
I don't. Are they even doing that?
That would be the reason to stimulate for prosthetics is.
All right,
to-
but I haven't even heard anyone talking about that. So is
Okay.
are they talking about that?
I guess that's always been one of the classic problems with proprioception is that you have with prosthetics is that you have to do vision guidance. You don't get the feedback.
Yeah.
So that would be like for me that's like the obvious application.
Okay,
of
but
this.
I haven't heard them talking about that because I don't think they even have a clue of how to do that.
Well, they could insert into S1 as well as motor
Just
cortex,
sending,
and then
sending
what could
information about
Yeah,
joint configuration.
but there's so many possible problems there that I don't think they're even. I need the prosthetic research. I've never heard anyone doing that. Maybe they are, but I've never heard that. But they're still just struggling to get it so someone can control an arm or move a mouse, something like that. And they're so far from. Unless you know something I know, that I've never heard anyone saying, "Oh, now we got it working. Let's worry about the proprioception part."
I think people have thought about the problem. I don't know if, but it'll be up to them to see if they can solve it.
Yeah.
So you could theoretically use to like insert in thought, vision, and ideas.
Yeah. The ultimate goal, what he wants to do, is that you're completely merged with the computer, so the thoughts go back and forth. So you can think the internet. You and the computer are one. That's where he wants to go.
But that's kind of crazy. Like, we have this wireless device that can insert thoughts in your head. I mean, how can that go wrong, right?
Well, you could argue that
You think?
your eyes are a device that inserts thoughts in your head, something like that, right?
Yeah, but I'm not at all worried about Facebook doing anything to
That's
my
like-
head. No, not at all.
It's like fake news at a whole different level.
Yeah, it's in kind of the medium term, there's all sorts of stuff that this is a few things from his video. I'm not going to play the whole thing. Let's see, is it? Yeah.
This is the talk again.
Yeah, this is the robot. I guess is the scale of the probes.
So he said, I remember he saying that this is not actually the probe. This is just, the probe is.
Yeah. The
Yeah. That's the needle.
Just the needle.
Yeah. This is the same video we saw here. These are the recordings. There's someone who's not Elon Musk on
This
stage.
is the CEO.
This is the packaging. Maybe there's not a whole lot here.
Oh, there's the guy in the script.
Yeah, Jeremy, for you. Oh, this is something about the patient experience. There's the guy.
Who's the guy? Who's the guy?
There's a guy in scrubs, a surgeon in scrubs on stage.
Are these sandals brought out? The robot? What is that?
The what?
Are they selling the probes, the robot? What are they doing with this?
I don't think they're selling anything yet.
He said he
They're
did
not
this.
selling anything,
He
no.
said what I read, and I didn't see him say it directly. What I read in a review said that the whole purpose of this presentation yesterday was to recruit people to work there.
He said that in the beginning, but only he. The other guys were like very excited. It was like Apple demo day. But Elon was talking about recruiting all the time.
So I don't know. It means he's having trouble getting people to work on this, or I can't imagine. I don't know.
He's
I
a
don't
hard
know,
guy.
but if that
Hard
was,
kind of work.
if that was the goal, I think it's pretty successful because it looks like neuroscientists are impressed
Yeah.
and people are impressed. So it's probably.
But he said the goal was to like sell to people, and he wanted like end of next year. So this could be the market. That's like.
Yeah, there was a slide that Andrew
and it's
had
gonna
about
be like
that.
taking a
Where is that?
basic surgery. You're just gonna go to the doctor.
Well, wait.
Yeah, this was the.
Well, I don't think he's saying, but I can't imagine he's saying by the end of next year that any person could do this.
Well, he
Not
said
any
for,
person. I think by end of next year,
Oh,
he's
that-
saying that there'll be inside human clinical studies.
These would be people who are paralyzed.
Yeah,
Yeah, exactly.
And you're trying to give them any kind of mobility, and they already do these kind of experiments.
Yeah, this is for quadriplegic.
Yeah, people. Yeah, they don't do this unless you're a shut-in almost.
Yeah.
You know.
So I think recording from M1 supplemental motor areas. I think this is thalamus. No, that's premotor, and then this might be what you were saying, Marcus. The closed loop feedback into S1 could be proprioceptive.
Yeah.
Able to use at home.
I was impressed how he said like you didn't needed a surgery. You just go to the doctor and in 1 hour you just complain of those stuff. So that's their goal. I don't know if that's.
How do they? Again, that would be.
Yeah. They said it's a 45-minute process of, I guess, after the skull is open. Just the insertion part is 45 minutes.
After the skull's open, so that's.
But it seems like they just open like a very small hole, I think.
No, if you're going to insert into all those areas, it has to be. It can't be a
I
tiny
think
hole.
there's two things going on here. There's what they got today and what it's going to be used for today, right? Which is, the sort of basic neuroscience research and open brain surgery and people who are quadriplegics. And then there's this dream of the future. And the dream of the future is you just go in and say, hey, I want a new brain implant. And they go, sure, Lucas, sit down here and, bingo, and it's all done. You don't have to have your brain opened up. And, I think that's where they want to go.
Yeah.
Because he wants to get to this to be like, this is the future of humanity.
Like everyone has one.
Everyone has one.
Installed
Okay.
at birth.
Hmm?
Installed at birth.
Installed at birth.
The USB-C connector.
Yeah.
PC, yeah.
And then it's neuroscience.
There's no headphone jack. What? What is this?
You know, there's like a device. Did you see that? So that this whole thing is gonna be connected to a device behind the ear.
But that's
Yeah, there was a
that's-
picture. There was
yeah.
a picture about that somewhere. I think it was in the New York Times.
Yeah.
Yeah.
But that's an artist's rendition.
Oh, okay.
Yeah.
So do you guys think this 2020 goal is viable?
For the quadriplegic, sure,
Yeah,
why not?
yeah.
They're already doing this stuff. Good. So yeah,
Just same technology that exists today, but
just better.
just better.
Yeah, I mean same type of application that exists today.
Okay.
You know.
Okay. Anything else?
It was interesting for me because I had just wrote about this, not knowing they were going to do this this demo. So it's like, oh, well, let's just see what I wrote, how it stood up, you know. Because I wrote about a bunch of things. I wrote about uploading of brains, and I wrote about this thing, and so I was a little nervous, like, oh gosh, you know. But I think I don't need to modify anything I wrote. My take on this, in case you're interested, was that this idea of uploading your brain to prevent being left behind by super AI, I think it's ridiculous because I don't think there is going to be super AI, and I don't think you need to be worried about left behind. And I'm not even sure you would want to do that. But my argument was that this is really useful for these kind of applications. We're already doing it. I mean, anything that be done to help the medical world would be great, and it's going to go on anyway. So who knows? Maybe in the future we'll find out that the technology that's developed for this kind of quadriplegic stuff becomes available to us for maybe additional sensory inputs that we find useful. It's not it's less of a merging with the computer, and it's more of enhancing our natural abilities. That's what I argued might happen. I still find it hard to believe that you could actually just totally merge with the computer. That would be sort of like the computer would have to be modeling on like a neocortex. You'd have to have the right kind of connections, and it all have to be very, very specific. So these are sort of broad. These are sort of very dull instruments in some sense. They just inject some current, or they abstract some signals. But not at the level of a billion neurons and high fidelity and that kind of stuff.
Do you think this type of work is going to help us understand what cortical columns are doing, or what
Only to the extent that neuroscientists use it, sure. Why not? We benefit from that work already, right? This is just another way of measuring neural activity. Yeah.
More recordings, more longitudinal would be extremely helpful for neuroscientists, right?
Yeah.
Because it's hard to get long-term recordings we discussed before.
Yeah.
Yeah. It may be hard to know exactly which layer you're in or which neurons you're recording from, but all this more data is helpful.
Yeah.
Okay. Thanks.
Yeah. Oh, that's
Great.
interesting.
Let me cut this one off here. Thanks, everybody. Thanks for watching.